Hi everyone, we're going to prove that the derivative of a log with base a, some number that's positive and can't be 1, is 1 over x, right here, times 1 over log base e of a. Function-wise, function notation-wise, that would be the derivative of log base a of my x is the derivative of my function times the function times log of a. So either way you want to write it. We're going to do the proof and an example. So the first thing we're going to do is start with our limit process to find the derivative. So that's going to be the limit as h approaches 0 of log base a of x plus h minus log base a of x over h. And like we did in the previous video, what we're going to do is pull out this 1 over h. So we're going to have this equals the limit as h approaches 0, and I'm just going to put the 1h out here. And at the same time, now I'm left with this piece, and I'm going to condense that because I have the same basis and write it as a single log. So that's going to be x plus h over x. And this little piece in here can be written as 1 plus h over x, because you divide both sides, both of these by x. So when we come to the other side, we're going to get the limit as h approaches 0, and we had that 1 over h, and what I'm going to do is use my power property of logarithms and put it as my power. Okay, then I'm going to rewrite this because I want it to look like that 1 over x like we did before. And we're going to have 1 plus h over x. And I'm going to ahead and write this as x over h times 1 over x. And the reason is I want this right here to be pulled out because I know the derivative of log base 10 is 1 over x. Okay, so now I'm going to go ahead and pull it out, and I can write this part inside here as e. This whole thing is e, so we're going to get equals log, let's do the limit thing, sorry. The limit as h approaches 0, and I'm going to write this part right here as e to the 1x, because this is, since they're both h's here, since they're constant, so this is going to be log base a of e to the 1x. And what I'm going to do is move this in front back as my power property, and I'm going to get this as 1 over x times 1 over log base e of a. Okay, so let's do an example. And when you do that, you're going to, let's do this one, y equals log base 2 of x squared plus 1. So when I take the derivative of this, I'm going to write this as what I have. So it's going to be 1 over my x, that's my x squared plus 1 times 1 over log of 2, because that's my base, times this top part, we could have done that earlier, x squared plus 1, and we take the derivative of that. So when you take the derivative of that, that's 2x. So what you're going to get is 2x over x squared plus 1 times log of 2. So the only difference between this one and the one we did earlier is that when your base is different, you're going to have to multiply basically the denominator by log of a. And then again, I'll write it out. So if you have a base different than base 10, you take the derivative of your function, which would just be 2x in our case, over our function, which is x squared plus 1, times log of a, which is what we did. This was the derivative of my inner function here. This was my inner function, and then we did log base 2. And also, let's note something else, that when you take the derivative with respect to x of log base a of x, it is the reciprocal of the logarithmic argument 1 over x. So it's the reciprocal of 1 over x divided by the natural log of base 8. So it's divided by, let's show you, ln of a, the natural log of a. So basically that means if we take the derivative of x, and then we have, write this out, log base a of x, that's going to be 1 over x, and this can just move up there, times 1 over ln of a. So it's kind of the same thing we did before, but last time we used log, and now we're using the ln, the natural log. Thank you. Have a nice day. Bye-bye.